Okay, hello everyone. We're going to solve the initial value problem y double dash plus 4y dash plus 3y equals 36x plus 18, where y of 0 equals 0 and y dash of 0 equals 0. So firstly, since y of 0 equals 0, this means that when x is 0, y is 0. And since y dash of 0 equals 0, this means when x is 0, y dash equals 0. Okay, so first we take the left-hand side of the initial value problem and set it equal to 0. Like that. And then we don't want it in terms of y, we actually want it in terms of lambda or alpha, whatever you prefer to use. So I like to use lambda, so we're going to go with that. So since it's a second derivative, we want lambda squared. So we write lambda squared plus 4 lambda plus 3 equals 0. So when it's a second derivative, it's a squared. When it's a first derivative, it's just 1 lambda. And when it's just y on its own, it's a 1. Okay, so now we've got this, we want to factorize it. So what times is to equal 3 and plus is to equal 4? So 1 times 3 is 3. 1 plus 3 is 4. So we know 1 and 3 are the numbers we want to use to factorize this. So for this, the factorization is lambda plus 1, lambda plus 3 equals 0. Okay, and now we can set each of these brackets equal to 0. So we've got lambda plus 1 equals 0 and lambda plus 3 equals 0. And rearranging these, bringing the 3 over and the 1 over, lambda equals minus 3 and lambda equals minus 1. So we know that y equals c1 e to the lambda x plus c2 e to the lambda x plus the particular solution of y. So we know so far that y equals c1 e to the negative x plus c2 e to the negative 3x plus some particular solution. Okay, so that's the first step. Now we actually need to find the particular solution. So to do this, we actually look at what's on the right-hand side of our initial question. So here we've got a polynomial, and this is in the form of ax plus b. So we know that our particular solution should be this. So yp of x is ax plus b. Now let's take the derivative of this. So yp dash is just a, and the second derivative, since this is a constant, is now 0. Okay, so now we need to substitute this into our initial question, which was plus 3y is that one. Okay, so we need to sub each of these into the left-hand side. So the second derivative was 0, the first derivative was a, and the initial particular solution was just ax plus b. So the reason why we're doing this is to find the values of a and b and what they should be. Okay, so now we can relate the left-hand side and the right-hand side together to find what a and b are. So let's first expand these brackets. So we've got 4a plus 3ax plus 3b equals 36x plus 18. Okay, so the constant on the left-hand side should be equal to the constant on the right-hand side. And similar to the coefficients, or the numbers in front of the x value. So the constant parts are 4a and 3b and the 18. So we know 4a plus 3b must be equal to 18. And similarly, the 3a should be equal to 36. So since 3a is equal to 36, a is equal to 36 divided by 3, which means a is equal to 12. So now we can take this 12 value and put it into here. So 4 times 12 plus 3b equals 18. Rearranging this gives us a value of b as minus 10. Okay, so from that, we know that the particular solution is equal to ax plus b, like we wrote earlier, and we know a and b now, so the particular solution is 12x minus 10. Okay, so if we go back, we knew that y equals c1 e to the negative x plus c2 e to the negative 3x plus the particular solution. So we know the particular solution now, so we can put that in. So y was equal to c1 e to the negative x plus c2 e to the negative 3x plus the particular solution. So y is equal to c1 e to the negative x plus c2 e to the negative 3x plus 12x minus 10. Okay, so now all that's left to find is c1 and c2. So to do this, we use our initial conditions, which was y naught equals 0 and y dash of 0 equals 0. So when x is 0, y is 0, and when x is 0, y dash is 0. Okay, so let's take the derivative of this one, because we know that we need to use the derivative just because we got given it. So we need to find the derivative of this one. So the derivative of this one is negative c1 e to the negative x minus 3 c2 e to the negative 3x plus 12. The 10's gone. Okay, so now we can apply our initial conditions. Let's apply it to this one first. So we know that when x is 0, the derivative of 0 is 0. The value of the y derivative is 0. So we know 0 equals negative c1 e to the 0 minus 3c2 e to the 0 plus 12. And e to the 0 is 1. So 0 is negative c1 minus 3c2 plus 12. Okay, that's our first equation. We can now apply the initial conditions to this one. So we know y is 0 when x is 0. So 0 equals c1 e to the 0 plus c2 e to the 0 plus 12 times 0 minus 10. So 0 equals c1 plus c2 minus 10. And that's our second equation. So now we need to solve these equations simultaneously. So we need to find the values of c1 and c2. So let's rearrange the second equation. Rearranging. So let's write c1 equals negative c2 plus 10. Okay, so we've got our two equations. I'll just write them again. So we've got 0 equals negative c1 minus 3c2 plus 12, equation 1, and 0 equals c1 plus c2 minus 10, equation 2, and we rearranged this one as c1 equals negative c2 plus 10. Okay, so since we know that c1 equals negative c2 plus 10, we can sub that in up here and replace this c1 with negative c2 plus 10. So 0 equals negative, because there's a negative out front of the c1, negative c2 plus 10, minus 3c2 plus 12. Okay, and now let's expand these brackets. So 0 equals c2 minus 10 minus 3c2 plus 12. So 12 minus 10 is 2. And 1c2 minus 3c2 is minus 2c2. Okay, and now let's bring this 2 over. So negative 2 equals negative 2c2. And dividing by this 2 now means that c2 is 1. Okay, and now we can pick either one of these equations that we want to sub into for C2 to find C1. It doesn't matter which one you pick. So let's just pick equation 2 just because it's easier. Okay, so we know 0 equals C1 plus C2 minus 10, and we found that C2 is 1. So 0 equals C1 plus 1 minus 10. So 0 equals C1 minus 9. And moving the 9 over means that 9 equals C1. Okay, so before, if we get a piece of paper from before, we had this equation up here. And all that was missing was our C1 and C2, which we now have. So we now know that y is 9 e to the negative x plus e to the negative 3x plus 12x minus 10. And that's our final solution. Okay, all done. So let's run through the steps real quickly. So you grab the left-hand side, set it equal to 0, change it to lambdas. Then you factorize it and find your 2 lambda values. And then you put it in this form with none of the constants found yet and a particular solution on the end. You then look at the right-hand side of the equation and see if it's an exponential. What type of polynomial is it? Is it is it trigonometry? Is it sine? Is it cos? Whatever it is on the right-hand side, you can also Google and see what particular solution you should use for different types of equations on the right-hand side, which is really handy to have a table right next to you when you're doing questions. So for our case, we had a polynomial in the form of ax plus b, so that's our particular solution that we choose. We take the derivative, and then we take the second derivative, and we get our initial equation and sub those in, like that. We find our a and b, and we get our equation, and then all that's left to find is our constants. We take the derivative, use our initial conditions of y of 0 equals 0 and y dash of 0 equals 0. We do simultaneous equations to find C1 and C2, put them in, and then we finally have our solution. Okay, thanks for watching. Good luck with all the math, and see you next time.